Grade 10, this is our objective for today. After going through this lesson, you are expected to find the sum of the first entrance of an arithmetic sequence. But before we proceed, may I request you to get your ballpen or pencil, your notebook or paper, as well as your calculator if you have, because we're going to use that on our activity, Something to Ask You. About if I let you add these numbers without using calculator? 1, 2, 3, 4, up to 100. Can you make it in a minute or two? Okay. You know that there is a little boy once upon a time who answered that in a minute or two? If you want to know him, read and listen. The story of Carl. Once upon a time, there was an elementary teacher who wanted to grade her pupils' papers. So, she thought of something to make her pupils in her math class busy. She then asked the class to get a piece of paper and add all the numbers from 1 to 100, hoping that it would take the class at least an hour to finish the problem. Much to her surprise, after a minute or two, a little boy whose name was Carl Friedrich Goss went over her and showed his work. She was so amazed to see his correct answer. This is how Carl did it. This is the little boy, who is now one of the greatest mathematicians, Carl Friedrich Gauss. Going back to Carl's idea, with 100 numbers, there are 50 pairs of numbers add up to 101. Therefore, 50 multiplied by 101 is equal to 5,050. How are you going to write 50 in symbols? What about 101? 50 is half the number of terms, which is n over 2. 101 is the sum of the first and the last term, which is a sub 1 plus a sub n. Therefore, the sum of the terms in an arithmetic sequence is denoted by S sub n is equal to n over 2 multiply the quantity a sub 1 plus a sub n. This is what we call as arithmetic series. Okay, so for you to understand more on arithmetic series, let me give you two examples. So let us have example 1. What is the sum of all even integers between 1 to 50? So when we illustrate that, it can be like this. So 2, 4, 6, 8, up to 48. Now, what are the given? So a sub 1 is equal to 2, and that is our first term. A sub n, which is 48, because that is our last term. And we have also d, which is the common difference, that is 2. So how do we get the 2? So when we subtract 4 minus 2, and 6 minus 4, 8 minus 6, the answer is 2. So that is our common difference. Now, we have the unknown n. So we don't know how many terms are there between 2 to 48. Then we're going to find their sum. So the unknown also is S sub n. Now, how can we find n? So to find for n, we're going to use the formula in getting the arithmetic sequence. So a sub n is equal to a sub 1 plus the quantity n minus 1 times d. So substituting for the formula, from the formula, so we have 48 is equal to 2 plus the quantity n minus 1 times 2. So 48 minus 2 is equal to 2n minus 2. Then we have 46 is equal to 2n minus 2. So 46 plus 2 is equal to 2n. Then 48 is equal to 2n. By simplifying, 46 plus 2 is equal to 2n. So therefore, by dividing 48 and 2 by 2, we can get 24. So next, how about to find for S sub n, or the sum of all the even integers between 1 to 50. So we're going to use the formula as we discussed earlier. So we have S sub n is equal to n over 2 multiplied by the quantity a sub 1 plus a sub n. So by substituting to the given, we have S sub 24 because we can see here that our terms are 24. So we can get the sum of the 24 terms. So we have 24 over 2 multiplied by 2 plus 48. So we can get the sum of the 24 terms is equal to 12 times 50. So this is equal to 600. So this is now our answer. So this is the sum of all even integers between 1 to 50. So what do you mean by that? So we can have 2 plus 4 plus 6 plus 8 plus up to 48 is equal to 600. So that's it. Okay, so let us have example 2. The third term of an arithmetic sequence is negative 12, and the seventh term is 8. What is the sum of the first 10 terms? Find the common difference, the first term, and the last term, which is the 10. So we're going to have the given. So a sub 3 is equal to negative 12. A sub 7 is equal to 8. That is our seventh term. Then, n is equal to 10 because we have the first 10 terms. Then d is equal to unknown, or we will find for the common difference. Then we have also unknown as the first term. So a sub 1 is question mark or question or unknown. And the last term is also unknown, which is a sub 10. Okay. We're going to have the S sub 10, or we're going to solve S sub 10 or the sum of the first 10 terms. Okay, so let us write in this way. So you can see that we have only 2 terms which are given according to the problem. So we have the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th term.
So, we will first find for the common difference. Okay, so lagay tayo ng bracket dyan. So, in order for us to have the first term. So, we will let a sub 3 is equal to a sub 1. So, we're going to make this as our first term first. So, by assuming we can use that as the first term, and a sub 7 is our fifth terms because we have 1, 2, 3, 4, 5 terms. So, now, by having this formula of arithmetic sequence, we can now find for D. So we can have a sub 5 is equal to a sub 1 plus the quantity 5 minus 1 times D. So we have 8 is equal to negative 12 plus 4D. Then 8 plus 12 is equal to 4D. So by simplifying, we can get 20 is equal to 4D, and by dividing 4 by 20, or 20 divided by 4, that is 5. So we have now our common difference, which is 5. So let us proceed. So we're going to find out the first term, or a sub 1. So we will use again the formula in arithmetic sequence. So we have a sub 3 is equal to a sub 1 plus the quantity 3 minus 1 times D. So that will become negative 12 is equal to a sub 1 plus 2 times 5. So negative 12, so we can see that this is our a sub 3. A sub 1 is unknown because that is our missing term. Then we have 2. We have 3 minus 1 times 3 minus 1 is 2, then multiplied by 5. So, by getting the additive inverse of 10, so we have negative 12 minus 10 is equal to a sub 1. So, by simplifying, we can have a sub 1 is equal to negative 22, and that is our first term. So, now, what about the last term? So, the important given in order for us to get the sum of these 10 terms are the first term and the last term. Okay. So, when you recall the idea of Carl Gauss, that is the important one. Okay, so a sub 10 is equal to a sub 1 plus 10, or the quantity 10 minus 1 times 5. So we have a sub 10 is equal to negative 22, this is our first term, plus 9 times 5. So always remember that n minus 1 here is important. So next, a sub 10 is equal to negative 22 plus 45. Then we have a sub 10 is equal to 23. So therefore, our last term is 23. So now we can already get the sum of these 10 terms. Okay. So now, what is the sum of n, or what is the S sub n? So using the formula for this arithmetic series, S sub n is equal to n over 2 multiplied by the quantity a sub 1 plus a sub n. So this is our solution now. So S sub 10, why 10? Because we have the total of 10 terms is equal to 10 over 2 times the quantity negative 22 as we get the a sub 1 and 23, and that is our last term. So we have now S sub 10 is equal to 10 over 2 times 1. So what is 10 over 2? That is 5. So therefore, the sum of all the terms from a sub 1 to a sub 10 is equal to 5.